Hello friends, Mr. Burrell here. In this lesson we're going to be extending our understanding of how to solve higher degree polynomial functions. Okay, in the last lesson we talked about how we can use long division to break down larger functions, larger polynomial functions, into smaller functions like quadratics that we already have other tools we can use to solve, to find the zeros. But that was conditional on me giving you one solution to start with. If I gave you one solution to start with, you could use long division and break that down into a smaller polynomial. Okay? Today we're going to talk about some other methods for solving these higher degree, higher order polynomials in addition to long division, and that I can use even if I do not have a solution to start with. You can always kind of guess and check what one of the solutions might be. And there's methods to do that we're not going to talk, effective methods to do that we're not going to talk about in this context, in this lesson. But the methods we're going to talk about today are methods we can use that don't require having a solution already. Okay, we're going to talk about something called quadratic type functions and something called factoring by grouping. Okay, so by the end of the lesson today, we're going to be able to factor quadratic type equations. I'll talk about what those mean. And we're going to be able to solve equations by factoring by grouping. Okay? So, first of all, let's talk about factoring quadratic type equations. Before I tell you what a quadratic type equation is, let's take a look at these two problems. Okay? What is the difference between these two equations? Okay? Take a second to think about it. Hopefully you notice that this equation over here is a quadratic. I know how to deal with quadratic functions. I have lots of tools in my tool belt for dealing with quadratic functions. This is not a quadratic function. It is a quartic function, but let's notice some of the similarities between these two functions. First of all, both of these equations have three terms. Okay? They all have the same coefficients on each of the terms. We have a 1, -2, -63 in both of those examples, okay? But notice the big difference between these two equations is the exponents. So notice in this problem, the x's in these terms have exponents of 4 and 2. The x's in this quadratic equation have exponents of 2 and 1, okay? So notice that to get from this exponent to this exponent to this exponent, I double the exponents, okay? I multiply them by 2. This goes from x squared to x to the fourth. This goes from x to the 1 to x to the second. This is what we call a quadratic type equation. It looks and acts a lot like a quadratic equation, but all the exponents are doubled, okay? Why is that helpful to us? Well, let's split the screen here. Let's solve this quadratic using methods we already know about, and then we'll use those properties, those steps, to explain how we can easily solve this type of equation. Okay, so x squared minus 2x minus 63. First of all, let's factor. Okay, here's my a, b, and c. I need to multiply a and c together and find two numbers that multiply to make negative 63 and add up to -2. Okay. So the two numbers that multiply to make negative 63 and add up to -2 are going to be -9 and +7. If you're struggling with that process, if you need help with that process of finding those two numbers, let me know. But those are the two numbers that multiply to make negative 63 and add up to -2. Okay? So in my factoring steps, I would rewrite this as x minus 9 times x plus 7. Okay? And then I would set both of those factors equal to 0. So I would set x minus 9 equal to 0. I would set x plus 7 equal to 0. Okay? And I would add 9 to the other side, subtract 7 to the other side. Boop, boop. I would end up with x equals 9 and x equals -7. Those would be my two solutions. And I knew there were supposed to be two solutions because my biggest exponent here at the beginning was 2. Okay? X equals 9 and x equals -7. I could even plug those numbers back in for the x's here and make sure that the whole thing is going to equal 0 to double check that I did it correctly. Okay? That's great. We know how to do that already. So now let's take a look at this problem. X to the fourth minus 2x squared minus 63. I'm going to solve this basically the same way. Okay? So let's pretend for a moment that this is a quadratic. Okay? If this was just a quadratic, x squared minus 2x, then it would factor out to be x minus 9 times x plus 7. Set that equal to 0. I would then set x minus 9 equal to 0 and x plus 7 equal to 0. And I would get x equals 9 and x equals negative 7. Okay? But remember that the difference between this function and this function is all of these exponents were doubled. So that is going to be true throughout this entire problem. Okay, let me change colors real quick. That means every one of these x's, even after I factor, the exponents are going to be doubled. So instead of just x's, I have x squareds. Right here, all my x's all my exponents are going to be doubled. Right here, all my exponents are going to be doubled. Okay? So now I'm not done solving yet. I have x squared equals 9 and x squared equals negative 7. Okay? Well, if I have x squared equals 9, what's the last thing I would need to do to solve for x if it's being squared? Well, I would square root both sides. Well, what's the square root of 9? Well, the square root of 9 is going to give me 3 and negative 3. Because 3 squared is 9, but also negative 3 squared is positive 9. So I'm going to get two solutions there, x equals 3 and negative 3. Right here, I'm going to have to square root both sides. What's the square root of negative 7? Well, whenever I have the square root of a negative, that means I'm going to have an I, okay? And then, so this negative is going to come out as an I. And what's the square root of 7? Gross, I don't know. It's some decimal that I'm not going to worry about it. Instead of writing it as a decimal, I will just leave it as the square root of 7. Okay? So my other two answers are going to be I times the square root of 7 and negative I times the square root of 7. Okay? Whenever I take a square root, I'm going to end up with two solutions, a positive and a negative one. So I have 4 solutions here, which is the amount of solutions that I was supposed to have. Okay? My solutions are 3, negative 3, I times the square root of 7, and negative I times the square root of 7. Okay? That is what factoring quadratic types is. It's when I have a polynomial function, a quartic polynomial function, that looks, feels, acts, smells a lot like a quadratic function, but all the exponents are doubled. Then I'm going to factor it just like I do a quadratic, and then at the very end, I'm going to end up, instead of just x equals and x equals, I'm going to have x squareds, which I will then finish solving by square rooting. Okay? Let's do another example. Okay, this is the one we already did. Let's take a look at 2x to the 5th minus 10x cubed plus 12x. This is not a quartic function, right? Right off the bat, this is not a quartic function. I have lots of weird things going on. I have a 2 in front. Lots of craziness going on. Right from the get-go, this doesn't look like a quadratic type equation. But let's see what we can determine when looking at this function, okay, this equation. First of all, and really a question that I should always ask myself before doing anything with a problem, is there a greatest common factor? Well, it turns out there is. First of all of these numbers, 2, 10, and 12, are all divisible by 2, but also every term has an x, okay? So I'm going to take out a greatest common factor of 2x, okay? When I divide each of those terms by 2x, I get x to the 4th minus 5x squared plus 6 equals 0, okay? That right there looks much more like a quadratic type equation. If I rewrote that as x squared minus 5x plus 6, that's just a quadratic I could factor. And this is the exact same thing with all the exponents doubled. So let's take a look at just this and factor. Okay, so I need to find two numbers that multiply to make 6 and add up to negative 5. Well, two numbers that multiply to make 6 and add up to negative 5 are going to be negative 2 and negative 3. Negative 2 times negative 3 is positive 6. Negative 2 added with negative 3 is negative 5. Okay, so I'm going to go ahead and write x minus 2 and x minus 3 equals 0. But remember, each of those x's need to be squared because the exponents are doubled. Which is going to leave me with x squared equals positive 2 when I add that 2 to the other side. And x squared equals positive 3 when I add that 3 to the other side. Okay? So now to finish solving for x, I am going to square root both sides of each of these equations. So the square root of 2, again, I'm not going to simplify that. The square root of 2 is a decimal, an irrational number. So I'm just going to write the square root of 2 and negative square root of 2. And then the square root of 3, I'm going to write square root of 3 and negative square root of 3. Note that oftentimes you'll see your answers written like this. Positive and negative square root of 2 and positive and negative square root of 3. Okay? Either way you write it, I don't care. So I have 4 solutions here. Right? X equals square root of 2, negative square root of 2, square root of 3, and negative square root of 3. But I was supposed to have 5 solutions. Right? That's what the fundamental theorem of algebra says. The biggest exponent tells me how many solutions I have. I only found 4. Where's the 5th? Well, notice this 2x that I took out as the greatest common factor, I would also need to set it equal to 0. Right? Anytime I have an x in a factor, when I'm factoring, I have to set it equal to 0, set that factor equal to 0 to find my solutions. So my last solution is x equals 0. So there are my 5 solutions: the square root of 2, negative square root of 2, square root of 3, negative square root of 3, and 0. And again, if I went in, and it might take a while, but if I went in and plugged each of these answers individually in for x in this equation, each one of them would make the whole equation equal 0. Okay? So there's another factoring quadratic type problem. Okay? So that's all the examples we're going to do with factoring quadratic types. Again, that's very similar to factoring just a quadratic. It's just all the exponents are doubled. So at the very end of the problem, we need to take into account that those x's, when I get my solutions, x equals, are going to be squared. So in order to finish solving, I have to square root both of those results. Okay? So we're going to shift gears a little bit. The last method in this lesson that we're going to talk about as far as solving higher degree polynomial functions is something called factoring by grouping. Okay? So this problem right here, x cubed plus 3x squared minus 4x minus 12 equals 0, this looks maybe more like one of the problems I would have given you in the long division section. Okay? I have a cubic polynomial. There are 4 terms. If I gave you a solution over here, like x equals 3 or something, I could use long division, and I could break this down into a quadratic function that I could then solve by factoring. Okay? But I didn't give you another solution. You don't have a solution to start with, and this is definitely not a quadratic type equation. There are 4 terms here and not 3, so there has to be something else I can do, okay? That something else you can do is called factoring by grouping, okay? So let's walk through the steps that I would use to solve this problem by factoring by grouping, okay? The reason this is called factoring by grouping is because one of the big steps is we're going to split this polynomial into groups, okay? You'll notice that since there are 4 terms, I could kind of visually split this polynomial into 2 groups. The first 2 terms being the first group, the second 2 terms being the second group, okay? So x cubed plus 3x squared becomes a group, and negative 4x minus 12 becomes a group, okay? Next, I'm going to treat each group separately, okay? So let me move my face out of the way here. I'm going to treat each group separately. So let me look at x cubed plus 3x squared and kind of ask the question that I should ask at the beginning of any one of these types of problems. Is there a greatest common factor? Let me erase this for a second. Well, x cubed plus 3x squared, they do indeed have a greatest common factor. They both have 2 x's in common, because x cubed is just x times x times x. 3x squared is 3 times x times x. So I have a greatest common factor of x squared, leaving me with x plus 3 in parentheses here for my first group. Okay, there's my first group. I just took out a greatest common factor. Let's take a look at my second group. I'm going to switch colors. Okay, my second group is negative 4x minus 12. Okay, well, is there a greatest common factor between negative 4x and negative 12? Well, yeah, both of those numbers are divisible by 4, and I'm going to do us one better and say both of them are divisible by negative 4. That'll come into play a little bit later. So I took out a greatest common factor of negative 4, and when I divide both of these terms by negative 4, that left me with just a positive 1x, and then negative 12 divided by negative 4 was a positive 3, okay? Here's a little visual of how I took out those greatest common factors, okay? So all I've done is I've taken each of those groups, each of those pairs, and I've taken out a greatest common factor in each pair, okay? So I want you to pay attention to this result that I've gotten after taking a greatest common factor out of each group. What do you notice between this group and this group? Okay? Hopefully you notice that both of these groups have something in parentheses, a factor that is the same. Both of these groups have an x plus 3. They have a common factor, if you will. Each group has a common factor, Okay? Well, if both of these groups have a greatest common factor, whenever I have a greatest common factor, let me give you some random other example. If I have 2x plus 4, I know that both of these terms have a greatest common factor of 2. So what do I do with that greatest common factor? Well, typically I pull it out in front and write whatever's left when I divide by that common factor in the parentheses. So if I had a greatest common factor of 2, I would write what's left, x plus 2 in parentheses. Okay? Well, if I have a common factor of x plus 3 between both of these terms, let me write that greatest common factor out in front. And then whatever's left, when I take x plus 3 out of both of those terms, I'm going to write in a second parentheses, x squared minus 4. Okay? That's kind of a new thing, kind of different than we've maybe done in the past. But it's the same principle that comes behind factoring out a greatest common factor. Both of these groups have an x plus 3 in common. I put that common factor in front. When I take them away, all that's left is x squared minus 4. Okay? So I'm left with this. Okay? Those parentheses, if I'm factoring by grouping, need to match. This x plus 3, this x plus 3, whatever's in those resulting parentheses has to match. If they don't, that means I either did the problem wrong or I can't factor by grouping. I have to do another method. I have to use some other method for solving this polynomial. Okay? So I have x plus 3 times x squared minus 4 equals 0. And if you don't believe that this is actually the correct factored version of the original polynomial, multiply these together. Okay? In fact, let's just do it while we're here. X times x squared is x cubed. X times negative 4 is negative 4x. 3 times x squared is a positive 3x squared. And 3 times negative 4 is negative 12. And indeed, that is the same as this. It's just out of order a tiny bit. The 3x squared and the negative 4x are swapped. But indeed, this is the same polynomial as what I got started with. It's just factored now. Okay? So, this form, when I have two factors multiplied together, is a form that I can work with. When I have two factors multiplied together and it equals 0, I'm going to go ahead and set both factors separately equal to 0 and then solve. Okay, let me move my face back down. So, x plus 3 equals 0. I'm going to subtract 3 on both sides, giving me x equals negative 3. X squared minus 4 equals 0. A couple ways I could solve this, but I'm going to go ahead and add 4 to the other side, giving me x squared equals 4. Well, what's the square root of 4? Well, that's going to give me x equals 2. And whenever I take a square root, I'm going to have a positive and a negative answer. So my two answers are 2 and negative 2. And then my third answer is negative 3. And how many solutions was I supposed to have? Thank you, English. I was supposed to have 3. This is a cubic polynomial, so I'm supposed to have 3 solutions. And there they are. Let me write them a little bit better over here. X equals negative 3, x equals negative 2, and x equals positive 2. Okay? And if indeed I plugged each of these answers back in for x in this original problem, it would make the whole equation equal 0. So go ahead and pause and do that if you need to confirm to yourself that we've done it correctly. But that's how I factor by grouping. When I have 4 terms in a polynomial, I can split it up into the first 2 terms and the last 2 terms and factor a greatest common factor out of both terms. Or both groups, thank you. Okay? Let's do another one. Here I have x cubed minus 4x squared minus 3x plus 12. This is a cubic polynomial with 4 terms. So let's factor this by grouping. Again, I'm going to split this into 2 pieces. The first 2 terms are the first group. The second 2 terms are the second group. Let's take a greatest common factor out of each group. So the greatest common factor here is going to be x squared, leaving me with x minus 4. Okay? What's the greatest common factor between negative 3x and a positive 12? I'm going to do something here. It's going to be incorrect for now, but I'm going to prove something. I'm going to show something here. Let's say I say the greatest common factor is 3. 3 divides into 3 and 12. Well, negative 3x divided by 3 is just negative x. 12 divided by 3 is a positive 4. What's wrong here? Well, first of all, these 2 parentheses are not the same. In order to factor by grouping, when I take the greatest common factor out of each of those groups, those parentheses need to be the same. They are not. They're close, right? So notice, right here, when I took out a greatest common factor of 3, let's take out a greatest common factor of -3. So let me put -3 here. Because -3x divided by -3 is a positive x, so just x. And 12 divided by -3 is -4. Notice now that both of those parentheses are the same. They're both x minus 4. Okay? So, I've done it correctly. I've done my factoring by grouping so far correctly because both of these parentheses are the same. Okay? So now each of these groups, this group and this group, have a common factor. That common factor is x minus 4. So I'm going to write x minus 4 out in front here. And all that I'm left with when I take away x minus 4 is x squared and minus 3. Okay? Now this is a problem I can solve. Now that this problem is completely factored, I'm going to set both of these factors, both of these parentheses, equal to 0. So I'm going to set x minus 4 equal to 0, which would give me a solution of x equals positive 4. I'm going to set x squared minus 3 equal to 0, which is going to give me x squared equals 3, which I then need to square root both sides to solve. So my answers are going to be x equals 4, x equals the square root of 3, and x equals negative square root of 3. Because anytime I take a square root here, I'm going to have two solutions, a positive and a negative one. And how many solutions was I supposed to have? 3. I was supposed to have 3 solutions. And there they are. 4, square root of 3, and negative square root of 3. And again, you can plug those numbers in for each of those x's and verify that your answers are correct because they will make the equation equal 0. Okay? Let's do one more example. Okay, yeah, one more example. We have x to the 4th minus 4x cubed plus 4x squared minus 16x equals 0. Let's try to factor this problem. How many solutions am I going to have here? I'm going to have 4 because the biggest exponent is 4. So when you see that 4, your brain might first go to, ooh, maybe this is a quadratic type equation because that first exponent is a 4. But notice I still have 4 terms. If I wanted to factor this like a quadratic type equation, there would only need to be 3 terms. So it needed to be something like, I don't know, something like that. This is not that case. I'm not given a solution over here, so I'm going to factor by grouping, okay? Before I factor by grouping, what I really should be asking at the beginning of all these problems is there a greatest common factor? Well, indeed there is, okay? All 4 of these terms have an x. So before I even split this into groups, I notice that there's a greatest common factor of x between all of these terms. So that's going to leave me with x cubed minus 4x squared plus 4x minus 16. Okay? Now, let's put our energy into factoring this cubic polynomial right here by grouping. Okay? So let me change colors here. I'm going to take these first 2 terms as the first group, these second 2 terms as the second group. Okay? So, what's the greatest common factor between x cubed and negative 4x squared? Well, I can take an x squared out of both of those, leaving me with x minus 4. What's the greatest common factor between 4x and negative 16? Well, I can divide both of those by 4, leaving me with x minus 4. Okay? And I know I did that correctly because both of these parentheses, both groups, have the same parentheses, that x minus 4. That's great. That's wonderful. Okay? And since both of these groups have a greatest common factor of x minus 4, I'm going to go ahead and write that in front, which leaves me with x squared plus 4. Okay? And the x that I took out as a greatest common factor, I better write back in. This is the completely factored version of this polynomial. Okay? So now, I need to solve. I need to set each of these factors equal to 0. So I'm going to have x equals 0, because x is just by itself. X minus 4 equals 0. And x squared plus 4 equals 0. So one of my solutions is just going to be x equals 0, right here. One of my solutions is going to be x equals 4, right there. When I subtract 4 here, I'm going to get x squared equals negative 4. When I square root negative 4, what do I get? Well, the square root of a negative, that means I'm going to pull an I out in front, okay? And then what's the square root of 4? That I know. The square root of 4 is 2. So one of my answers is going to be 2i, or I times 2, or I times the square root of 4, doesn't matter. and negative 2i, because whenever I have a square root, I'm going to have a positive and a negative answer. So those are my 4 solutions. X equals 0, 4, 2i, and negative 2i. Okay? And that's good because I was supposed to have 4 solutions. Okay? So that's it. That's factoring by grouping. So in this lesson, again, we've talked about factoring quadratic type equations and factoring by grouping. Those are the 2 big methods besides long division that we will use to factor larger degree polynomial equations and find the solutions. Okay? So key things to watch out for in quadratic type equations. Okay? We're looking for something like this. Okay? Where it looks like a quadratic, but these exponents are doubled. 3 terms, 4th degree. That's what I'm looking for when I'm solving a quadratic type equation. Factoring by grouping is going to look something more like this, where I have 4 terms, and typically, unless there's a greatest common factor, I need to take out first a 3rd degree. Okay? So there you go. Hopefully that was helpful. I hope you learned a lot. Please let me know if you have any questions, and I hope you enjoyed that as much as I did.